This is the video solution to one of the example problems in rotational kinematics. During a hand prop starting procedure, when the propeller is at 0.383 radians, it's moving at 1.1 radians per second. At 2.51 radians, it's moving at 4.67 radians per second in the same angular direction. What is the angular acceleration of the propeller? So let's start with a little diagram. Here I have everything set up. On the diagram you can see I've got the initial conditions and I've got the final conditions shown on the diagram. It doesn't matter if I turn clockwise or counterclockwise, it's all going to be in the positive rotation whichever way I choose. It also doesn't matter where you consider 0 to be, so I just chose straight up at 12 o'clock position. Okay, before I come up with a strategy, let's start by listing what I know. That's the givens. So when I look at the givens, I've got the initial angular velocity, the final angular velocity, and the initial and final angular position or angle, as well as I'm looking for the angular acceleration. Since this is circular motion, I'm going to start with my strategy relating to circular motion concepts. Given what I see on the left-hand side, that's going to give me a hint that I can solve all this with rotational kinematics. So I'm going to use the equation omega naught squared, or omega squared equals omega naught squared plus 2 alpha theta. But remember, in this equation, theta is actually delta theta. So that's the first thing I need to find is delta theta. So to find the change in the angle, I need to have the final angle minus the initial angle. So the 2.51 minus 0.383 radians to give me 2.127 radians. So that's the theta that's going to be used in the formula. Make a little bit of room, and then I'm going to find the angular acceleration from my rotational kinematics. So I'll use my equation. So you can see I'm showing the equation, the next line, the number in units, a little bit of math, and I get the angular acceleration to be 4.84 radians per second squared.